So now we're going to transition from having one variable with multiple populations, two or more, to measuring the relationship between two categorical variables. And this gets into the idea of, are these variables independent or not? So this is going to be the chi-square test of independence. So here you'll notice they did a random sample of 8,474. They took one random sample, and that's your table total. Where chi-square test of homogeneity, they would take independent random samples. They might randomly sample people with low anger, people with moderate anger, and people with high anger. And we'd see if this heart disease rate was the same across all three populations. Not the case here. They're randomly sampling this almost 8,500 people and asking them two questions. Rate your anger level, and did you have CHD, yes or no? So we're measuring two variables. That's what makes this a chi-squared test of independence. Guy looks just angry. Or like he's going to start laughing. I can't tell. All right. So again, with the bar graphs, not going to spend too much time there. That's not going to be a big focus of this. So there's two ways you can list the hypotheses for independence. You could say the null is that there's no association between variable 1 and variable 2 in context. Or you could say variable 1 and variable 2 are independent. Depends what you prefer. So no association means the same thing as independence. If there is an association, that means that variables are not independent. So that would be the opposite there as far as the alternative goes. So I'd say pick one, be consistent, but realize you might see both on an AP exam. The way that you calculate your expected counts is exactly the same as a chi-square test of homogeneity. Row total, column total, table total, done. Conditions, exactly the same. The way that you do it in the calculator, exactly the same. The only difference is the way the data is collected. Chi-square test of independence, they're taking one random sample and collecting two variables. Chi-square test of homogeneity, they're taking either independent random samples or there's an experiment with multiple groups and you're comparing the distribution across those groups or populations. So summary, as I mentioned before, there's two ways you could state the null and alternative. Chi-square test statistic is the same. The way that we calculate the p-value is the same. The way that we get our expected counts is the same. Okay. Degrees of freedom are calculated the same way. It's going to be the number of rows minus 1 times columns minus 1, not including the totals. All right. Okay. So what I would do is read through this question, pause the video, work through your 4-step process, and then play it back. Watch me kind of go through it with you. So I see a two-way table. As soon as I see a two-way table, my only options are test of homogeneity or test of independence. Then I'm going to look for what they said about the random sample or random assignment. Here I can see a random sample of 170. That's the table total. That's one random sample. This has to be a chi-square test of independence. If it said random samples or random assignment, chi-square test of homogeneity. Other hints, it says, do they provide evidence, blah, 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 of a level of association, of an association. That's another way of saying that they're not independent. Okay, test of independence. So the null hypothesis, there's no association between these two variables. The alternative, there is an association. For the plan step, there was a random sample of 170. 170 is less than 10% of all new franchise firms. And large counts, all the expected counts that I'd get from the matrix in the calculator, I can list them out. I have to list them somewhere. As I mentioned before, I just put a little slash here and write in the expected counts and then put a little key observed / expected so my AP reader knows exactly what I'm talking about. Your test statistic, 5.911, and your degrees of freedom are 1, 2 rows minus 1, 2 columns minus 1, 2 minus 1 times 2 minus 1 is 1. And your p-value ends up pretty small, 0.015. But the significance level is only 1%. So we're actually over that. We're going to fail to reject the null. and it does not, we do not have convincing evidence of an association here. So this last part is just talking about making sure you choose the right type of test. It's the way that the data is collected. So here, a random sample of 117, one sample of the whole table total, chi-square test of independence. If it was random samples of, say, 38 and 79, chi-square test of homogeneity. Okay. I don't really want to get into that. Okay, that's that. All right, so summary. We have two different tests that come from a two-way table. Chi-square test of homogeneity is one variable with two or more random samples, or one variable with a randomized experiment. If it's an experiment, it has to be a chi-square test of homogeneity. And then the chi-square test of independence is a two-way table, just like homogeneity, but there's only one random sample being taken, and we're measuring two variables from each person or thing in that random sample. Test statistic is the same calculation. The expected counts are the same calculation. Degrees of freedom are the same. The way we do the conclusion is the same. So the only difference will be in the way the data is collected and your hypotheses, and then the name of the test. Everything else is going to be the same. So I think this goes through how to do a chi-squared test on the calculator. We'll cover that in class. That's about it. That's the end of section 11.2.